Hello, guys. Thank you for joining us for the third Airflow meetup. This time it's a webinar because of the one main reason, like to reach wider audience, of course, and of course to because we have Daniel this time. Daniel Imberman, if you don't know, he has already contributed significantly with bringing Kubernetes capabilities with Airflow. So you can run your Airflow on Kubernetes, Kubernetes Executor, also run jobs on Kubernetes Pod. Yeah, so thank you, Daniel, for your contributions. Also, for the people who don't know, we have selected Daniel to be a core contributor of the Airflow project. So he would be now a core part of the team, and he would be contributing even more. And yeah, and I'll head the mic to Daniel now. Daniel,
Absolutely. Can you hear me, Kexel?
yeah.
Great. Yeah, thank you everyone for coming. So I'm going to try to keep the talk section somewhat brief, just kind of give an overview of what we offer Kubernetes-wise, what's on the roadmap, and just what some deployment options are, because I want to definitely open this up to conversation and to any questions people have about running Airflow on Kubernetes. So let me just share my screen. So yes, thank you for coming to my talk on Airflow and Kubernetes. So to start out with, we're all here for the same reason. And that reason is because pipelines are hard. Essentially, as fellow Airflow enthusiasts, you all know that what can start out as a pretty simple A to B can become pretty complicated in pretty unexpected fashions, and things can go wrong, and no company runs a single pipeline, so you're managing lots of pipelines, and that's why we all love Airflow. So I'm not here to sell you on using Airflow, but rather, why do Airflow on Kubernetes? And this was an important question we asked ourselves when we were first starting this, because we didn't just want to offer, say, like a Helm chart with Airflow on Kubernetes, and then you deploy it and that's your Airflow Kubernetes solution. We wanted to honestly figure out what are the benefits that Kubernetes offers and how can we take advantage of those benefits to improve the Airflow experience. And when we thought about it and we kind of did more research, we realized that the big things that Kubernetes offers are more flexibility, because you can now launch arbitrary Docker images, a better story around dynamic resource allocation, because Kubernetes allows you to very easily build up and tear down images or tear down containers. And thirdly, a lower barrier for entry, because Kubernetes is made that you can do very complex deployments in a single YAML script and in a way that people who don't know the nuts and bolts of what's going on inside can still handle, have these complex applications. So with that, we came with a few solutions. So I broke this up into a few pieces. The first section, we're going to talk about what is the Kubernetes pod operator versus the executor. That's a question we get pretty commonly. So I want to kind of describe the difference between the two. Why would you want to use the Kubernetes executor? And then finally discuss what the current and future deployment options are for running Airflow on Kubernetes. So to begin with, the Kubernetes pod operator is essentially a Docker launch operator. So while there is a Docker operator in Airflow, what we found was that wasn't about launching a Docker container as much as it was communicating with one. So we wanted the ability to launch an arbitrary Docker image on Kubernetes. So this allows you to offload a lot of the dependencies that you would normally have in Airflow to these Docker images. So you can run your application, you can run things with a lot of internal libraries, and it allows you to kind of let Airflow focus just on the scheduling aspect. So it speaks to Kubernetes, it launches a pod, it waits for that pod to complete, and then it will monitor it and return any passing or failing of the task you attempted to run. So in the common example, like let's say we had a DAG that had tried to run a Python script on two different images, one of which is an image that has Python within it, and the other one does not have Python. The first one will pass, the second one will fail, and both of those results will be given back to the user. This is really nice, especially when it comes to rollbacks. So if you are versioning your DAGs, you can actually version based on image tags what version of your application you're deploying to run that task. So it makes everything even more predictable. But to me at least, the more interesting addition was the Kubernetes Executor, because the Kubernetes Executor is it's a completely different way of actually how Airflow runs your tasks. And this is where we really try to change the Airflow experience to take advantage of a lot of the benefits of Kubernetes. The biggest thing we wanted was dynamic resource allocation, where essentially the biggest complaint that we got when we talked to a lot of Airflow users is that when using Airflow in parallel with things like the Celery Executor, you have to kind of determine ahead of time what your what size cluster you want to use. So you have to set up a static cluster of workers, and this can require either over provisioning or under provisioning. And then you also have to kind of set up these workers with all of the dependencies in them. So, if you have a cluster, there might be a point where you just get absolutely slammed, and then suddenly you're not meeting your SLAs, which can be really bad if you have tasks that are waiting behind other long-running tasks. So then you grow out your cluster, which leads to over provisioning, where suddenly you just have these Airflow workers eating your EC2 bill or eating electricity, and that's also not good for having an optimal setup. It's also the case that with a lot of these setups, you end up with you have to manage a lot more technologies. So with the Celery Executor, for example, you have to now learn how to manage Celery. You have to set up Flower for debugging. You have to have a Redis or RabbitMQ backend. So you're now running 4 or 5 different technologies just to be able to have a workflow scheduler. So we wanted to really simplify, just be able to launch Airflow and do so in a way that you don't have to think about this static allocation ahead of time. So that's where the Kubernetes Executor comes into play. Essentially, we take advantage of Kubernetes to allow for dynamic allocation, which created a lot of really cool benefits for things like task-level pod configuration, fault tolerance, and a simpler deployment story. When it comes to the dynamic allocation, the way that it works is these Kubernetes Executor runs as just a single pod that's only running Airflow. And when your DAG is running, it speaks to the API and it launches launches a brand new pod for every single task that you run. So that allows for dynamic scaling out. And then when your job is done, it shrinks back down to a single scheduler pod. And that because each pod is running completely new every time, this allows us to have this option for executor configurations. So now you can decide, well, this pod is only requesting a Spark job as opposed to another task that's doing some SciPy operations. Therefore, they might need very different. They might need very different memory requirements. And when it comes to actually choosing an image of Airflow to run for a specific task, where we've seen a lot of companies get a lot of value from this is, let's say you're doing tasks that require certain C++ bindings or require certain Linux packages that you don't want to have to distribute to every single other task that you're running. You can actually set up a lot of the lower level dependencies in that specific Airflow version built on top of the base Airflow one. And that way you prevent each of the pods from getting too big or the dependencies from getting too complicated. And of course, we also offer secret management, where now you can determine which tasks have access to which of your service accounts or secrets, which kind of makes for a better security isolation story. This also means you no longer have to think about capacity planning, and you no longer have to worry about time-sensitive jobs not meeting their SLAs. Just a real quick overview of how the actual architecture. When you're running things via the Kubernetes Executor, the way that we allow for a lot of scalability is the scheduler no longer receives whether the task passed or failed, because the workers are actually all able to speak to the same Postgres instance. So they're able to report back whether the task passed or failed without speaking back to the scheduler. And the only thing the scheduler is actually monitoring for is one of the worker pods dies. And it does that via reading what's called a watcher thread, which in Kubernetes is just a way of reading an event stream. And through this event stream, it can actually see what the status of each of the tasks that are running is. But we also wanted to make sure that we had a good fault tolerance story. So we wanted to take it. There's a part of Airflow architecture where certain information that's pretty valuable is actually kept in local memory, and we wanted to make sure that if the scheduler goes down, that we don't either lose tasks or double run tasks or do anything that might create for an unideal DAG execution. And we're able to do this taking advantage of a feature in Kubernetes called a resource version. And what a resource version is with that event stream we were talking about, every single event has a monotonically rising number. And by tracking that number and storing it in the SQL instance, we can have the scheduler go down for hours or days, come back up, know what the most recent resource version it read is, and then replay the event stream to make sure that anything that was basically recreate the state from scratch. So you have a good fault tolerance story that is now tied in with the Kubernetes that you're running. And of course, you also get the benefit of monitoring, where you get the monitoring tools of the existing Kubernetes infrastructure, which oftentimes includes things like Prometheus. And if your DevOps have set up Logstash daemons within your nodes, then all of your Airflow logs will automatically go to Elasticsearch, where you can set up Kibana dashboards. And now let's chat a little bit about what current options there are for deployments. So the most common one that people are currently using are what are called Helm charts. And what Helm charts are opinionated pre-built templates that exist for a wide array of applications. There's a Helm chart for Spark. There's a Helm chart for all sorts of different types of things that you would want to deploy in Kubernetes. So I've included a link to pretty well-maintained Celery version and Kubernetes Executor versions of an Airflow Helm chart. The downside to Helm charts is that they require what's called a tiller, which is a bit of a super user on your cluster. So Helm 3 is going to come out without this tiller, but it's a bit of a controversial topic within the Kubernetes world. And because of that, a lot of people in the Kubernetes community believe that slightly more believe in what are called operators, essentially. And what an operator is an operator is essentially a way of treating a custom resource as if it's a native resource. And what that means is, when you're using Kubernetes and you request a pod, there's something called a custom controller. And what that custom controller is a state machine. So you request a pod to Kubernetes, and there is a pod controller that says, okay, this user requested one pod, there's currently 0 pods, therefore I need to launch a new pod. Kubernetes makes it very easy to extend this to do any number of things that are higher level. So some of the members of the Google Cloud team were nice enough, were able to essentially create an Airflow pod operator, or an Airflow operator that makes an Airflow resource. So you can actually just send in a YAML that says, this is the Airflow I want, this is the configuration I want in this Airflow, and Kubernetes will treat it like a native resource and then give you an Airflow instance back. So I've also included a link to that. What I will say is I'm actually going to be, in the next couple of weeks, pretty active in making sure that we update this operator, as well as this is actually the one that I would hope becomes one of the default release versions of how to launch Airflow in your Kubernetes cluster. But the way it essentially works is it speaks to the Kube API, and then it launches the Kubernetes Executor. And this is an example of what that YAML would look like. So you can basically, with the UI, do like set the version, set the Git repo, and then kind of point to where the DAGs are. We offer multiple ways of actually storing the DAGs, be it persistent volumes, Git repo, or baked into the machine. And with the Airflow operator, you can also set an affinity where you can actually say which nodes you want to be able to run your Airflow workers on. So that way, if a specific node goes down, you can actually do some load balancing to make sure that your tasks are still able to run. As I mentioned before, there's the 3 modes of DAG propagation. For small to medium-sized instances of Airflow, if you're not running just thousands of DAGs on a single instance, I would definitely recommend Git init mode or pre-baked mode. But the persistent volume mode is also fine if you have that infrastructure set up. So if you already have someone that's, if you already have NFS within your Kubernetes cluster, or you have something that can tie into the Kubernetes persistent volume API, that also works just fine. So Kubernetes Executor has been released in Airflow 1.10. I think we're going to take it out of experimental mode for Airflow 2.0. We have multiple companies using it in production. We have an active community in SIG Big Data on the Kubernetes Slack, but we also want to start pushing people towards using the Airflow Slack. And in doing so, we want to kind of I will be on that Slack pretty often, so feel free to ask me questions. And there's also a pretty active community of users that will be able to, who are currently running it in production, who will be able to answer questions as well. And as far as what's next, we're looking to kind of do a feedback and iteration round, where essentially we've now had companies running this executor in production for a while. We want to go back to those companies and say, what are the pain points you've been dealing with this project? How can we help? How can we make this better? So if you are a company that is currently running in production, definitely please reach out to me. I'd love to be able to ask more questions and find out where your pain points are. I'm also hoping to pretty soon start doing every 2 weeks, have virtual meetups or office hours to have discussion about prioritization. And this would also be a great place where if you are interested in getting involved in the effort, come to these meetings, because then we can talk about what things that we would need worked on and turn those into tickets on the Airflow Jira, and then that would be a great way to get involved. I'm also really excited to say that pretty soon, after taking a quick vacation, I'm going to be joining astronomer.io, and that is going to give me a lot more time to focus on basically really kind of digging in and helping the Airflow community, helping the Kubernetes executor, adding better CI/CD, and really helping this new effort to take Airflow to the next level. And I'm really excited about that opportunity. I want to say thank you to everyone who came. I also want to say thank you to Barney Seethraman, who created the Google Cloud Airflow operator for launching Airflow within Kubernetes. And I also borrowed some of his slides, so thank you for that too. And yeah, I'm glad to take any questions that anyone has.
Thank you, Daniel. Thank you very much. That was quite useful. Yeah. And if anyone has questions, please post it on the YouTube channel. So we can take, let's wait for if someone has some questions out there. But yeah, well done. And congratulations, by the way.
Thank you.
The great news. I think it is going to be good for the community itself. You spending more time on Kubernetes and Airflow would help the community excel more. Do you have any advices for someone starting out with, let's say, Airflow, and they are just looking into whether they should use Celery Executor or Kubernetes executors?
Yeah. So the biggest piece of advice I give is, if you're not already using Kubernetes, keep in mind that starting Kubernetes from scratch is itself a bit of a tech debt. So if you already have a Kubernetes cluster or have a team that's working with Kubernetes, absolutely try the Kubernetes executor. It offers a lot of really cool advantages, but unless you are planning to do other things on Kubernetes, it will be a lot of overhead to learn Kubernetes from scratch to use the Kubernetes executor.
So if the workload is small, I think you would still advise people using Celery or maybe local executor, right?
Yeah, I would say for really, if you're just starting out, and you just kind of want to test out, you have a few simple DAGs, nothing that takes up a lot of space, start out with the local executor just to kind of get used to using Airflow. And then when it comes to scaling, then decide if you have easy access to a Kubernetes cluster, then kind of figure out if you want to run the Kubernetes executor. One thing to mention is you don't actually have to run the Kubernetes executor in Kubernetes. You just have to have access to the Kubernetes API. So if you have certain rules about what you're allowed to do with machines in your production Kubernetes cluster, you can absolutely run it on a separate machine and just have it act as a launcher via the API.
Yeah. So Taylor asked, can you share your slides? I think we will do that after the talk, maybe tonight or tomorrow.
Absolutely. I'd be glad to.
Yeah. So Jerem asks, what do you use for visibility into the Airflow infrastructure, that is monitoring jobs and CPU?
So that's kind of where I was talking about. So for monitoring the actual health of the nodes, Kubernetes there's a lot of really good stories around monitoring within Kubernetes. So things like Prometheus will kind of monitor the health of the machines. You can also use the Kubernetes dashboard to see which comes like natively in the cluster. But what's really nice about running it in Kubernetes is that you get to take advantage of a lot of existing infrastructure that's not Airflow specific.
Yep. Do we have any more questions? If not, I can find some questions, definitely. Okay, so Daniel asks, being able to execute almost any task with a Kubernetes operator, does it make sense to use also Kubernetes Executor?
I would say so. And the reason, this is actually a question I get very commonly. The Kubernetes operator and the Kubernetes executor do very different things. So what the Kubernetes operator does is give you that ability to just launch an arbitrary Docker image. But you still, with the Kubernetes executor, get that ability to size up dynamically, get the ability to get that fault tolerance, to have that easy deployment, easy management, because you no longer have to manage Celery or Flower or any of the other backing technologies. So I think they work together very nicely, personally.
Okay. So would you have a Kubernetes cluster and directly use Kubernetes Executor? Or I think you already answered it, but just for the viewers, that would you have Celery and then just use Kubernetes pod operator?
I would personally use the Kubernetes executor and Kubernetes pod operator.
Yeah.
Because like I said, because they both have very distinct benefits. If you already have the Celery executor set up, and there's no reason why you can't use the Kubernetes pod operator on the Celery executor. But if you're starting from scratch, consider the overhead. If you're starting from scratch and already have a Kubernetes cluster, you have to consider the overhead of learning how to manage a Celery cluster as well, and as well as whatever Redis or RabbitMQ backing you're using for Celery.
Yep. Jerem asked, would you run Airflow inside of Fargate?
I haven't looked into Fargate too much personally, so I unfortunately can't answer that.
No worries. Christian, are there any other ways aside from Kubernetes you have seen dynamic scaling of Airflow worker nodes?
I have not. I remember when I first started, I thought that's what the Mesos executor did, and it took me a while to realize that the Mesos executor was actually still speaking to a static cluster.
Yeah, I don't think so. I don't think other than Kubernetes Executor, there is a way of dynamically scaling worker nodes, Christian. Yeah. Any more questions, guys? So how do you use Kubernetes Executor with Bloomberg? Do you have a big enough cluster?
So as far as at Bloomberg, Bloomberg is still pretty early in kind of Airflow adoption. That's purely because the team that I am currently in the process of transitioning out of, we handled a lot of different open source projects at the same time. Airflow was just part of a larger data science platform. I can't speak too much further into that, but I will say that I've still been while the case at Bloomberg has been pretty early, I've been able to work with a lot of other companies that have been running it in production and speak to their use cases.
Okay, yeah, cool. I think we don't have any further questions. Okay, we have given someone is asking one question. You, message detected. What happened? Daniel, your message got rejected for some reason. Can you type in your message again? Okay, so does GCP Composer offer dynamic scaling of Airflow worker nodes? Do you have you used Cloud Composer?
I have not personally used Cloud Composer, but I do speak. I have not personally used Cloud Composer from GCP, but one of the first things I plan to do. So among the things I plan to do with my new role at Astronomer, I'm really excited to kind of like see what a lot of these offerings are like. So I definitely plan to do some testing on Cloud Composer to be able to see the things that like it offers that I do like, see the things that I don't like, see where from an Airflow community standpoint, like we could be improving that experience as well. But also, one thing I also want to mention is one of the other things I'm going to be working on is heavily improving, like working a lot on documentation and kind of coming up with making sure that there's lots and lots of simplified on-ramps into the Airflow community, I guess is the best way I would put it.
True. And as far as I have used Cloud Composer, I don't think, Adriana, that there is a dynamic scaling of worker nodes. Sorry, Adi Narayana, I don't think we have dynamic scaling of Airflow worker nodes in Cloud Composer. Jerome asked, what resources did you use in getting started with Kubernetes or Airflow?
So I was a Kubernetes guy before I was an Airflow guy. And I will say the Kubernetes community has been unbelievably helpful on this effort. There's a group in Kubernetes. They just recently changed their name from SIG Big Data to User Groups Big Data. And this group was essentially, it was and is essentially tasked with trying to get big data open source technologies into a native Kubernetes form. So they handled the Spark on Kubernetes, Kerberized HDFS on Kubernetes, and like they met, but we would meet every 1 or 2 weeks, and I would come to them with my ideas about the Kubernetes executor, and we would have a great discussion. So I would say for both Airflow and Kubernetes, both of them are going to have like really good Slack cultures. I definitely want to start pushing the Airflow community to start using the Slack more often. And for the Kubernetes side of things, I would definitely say look up, like Kelsey Hightower has a really good up and running with Kubernetes book.
Yeah.
Lots of really good talks from, if you look up KubeCon, there's a lot of really good talks on the internet from there. So those are where I would say starting out with Kubernetes resources.
How about you can compile a list of top 5 resources you liked and we can send over to the guys?
Absolutely. I'd be glad to do that.
Awesome. Thank you. Thank you. We have got a few more questions. Chris asks, can you give a quick example of how you would dynamically scale a large database job? Would you set your resource limits based on the amount of data volume?
So I guess I'd have to ask a little further. When you say a large database job, are you talking about like an ETL, or like are you pulling data from somewhere into the Airflow instance and then sending it somewhere else, or are you just sending a database query? Because one thing I would always personally advise is try to make the Airflow workers do as little as possible. That's one of the big benefits of the plugins, is that you should be try to take advantage of the APIs of whatever external technologies you're using. But if you want to describe your use case a little bit more, I'd be glad to go into more detail about that.
I think Chris says it's for the ETL.
Yeah, so if you're doing like an ETL, like trying to move something from one database to another database, you of course have the option of setting it up where you could essentially pull from one into the Airflow instance and then push to the other one. I think there might even be a SQL to SQL operator, but this is one of those cases where I highly recommend, if you are, say, like an Airflow team at your company, making custom plugins, like making custom operators for your data engineers will reduce the complexity of the DAGs, which will reduce the complexity of the bugs they run into. So if there's something that people are doing very often and you can kind of templatize that into a custom operator, I highly recommend doing so.
I definitely agree with Daniel. I have faced multiple instances where, like, lots of people in my team have wanted to do the same task and they had to use like 5 to 6 operators. So when you know that you are going to use the same set of operators every time, just create one more custom operator and tell your team to use that instead. I think that would be more beneficial in the long run. Plus, it means that you would maintain idempotency as well. So yeah. Uh, Maton asks, would you deploy test dev prod environment of Airflow to the same cluster?
Sorry, can you say it one more time?
So Maton asks, would you deploy test dev prod environment of Airflow to the same cluster?
No, I highly recommend, if you are running Airflow. I'm sorry, just as a general Kubernetes rule, you should absolutely have a dev and a prod cluster for Kubernetes, because you want that isolation. You don't want any risk of cross contamination.
Okay, so here's an interesting question that Daniel asked. Given the flexibility of Kubernetes operator, would you still recommend using other operators at all?
It really depends what you're trying to do. So, for example, if you're like, I would definitely recommend, for anything of like complexity, you're definitely better off using the Kubernetes pod operator, because you want to like offload that complexity. But if you're doing something where there's already an existing plugin, and you can keep in mind also, you can extend plugins. Like, there's no reason why you can't take the pod operator and then build like a higher level plugin over it, so you don't have everything just say Kubernetes pod operator over and over again.
True.
So you can basically make a higher level plugin that does the Kubernetes pod operator with a specific image and a specific configuration.
Yeah, so for example, passing some default parameters like your chat name and something like that, I guess.
Mm-hmm.
Yeah. Okay, a few more questions. Last 2 questions.
Sure.
Esker asks, Kubernetes operator is only for a task, but the executor is for the entire DAG, right? If you use the executor, you can get the full insight in Airflow in every task running there, unlike the operator.
Yes.
Yeah.
That's exactly it. Like, the Kubernetes pod operator, that one task will run in Kubernetes. Kubernetes executor, all tasks will run in Kubernetes, and all tasks will get the benefits of Kubernetes.
I think I see a lot of people getting confused between the operator and executor. Maybe we can, update our documentation and make it more clearer, I guess.
Absolutely. Yeah, I would agree with that.
Yeah. So the last question from Andrew, he says, would you ever use Kubernetes node affinity with Airflow?
Absolutely. We recently, I believe in 1.10.3, we patched in the ability to do custom annotations on your tasks, and with that, like, there's lots and lots of use cases where you would want a node affinity for certain types of tasks. Like, it might be that you want data locality, like you might be running like a multi-region cluster, and want that task to run in a region close to where the actual data is living. There's there's absolutely use cases for that.
Awesome. I think let's wrap this up.
Okay.
Yeah, thank you, Daniel. That was a great talk, and yeah, thank you for all answering all the questions as well. And again, congratulations for going to Astronomer, and I hope and I'm sure that you will spend some more time now with Airflow, and the project would benefit definitely because of that. Thank you for the nice talk.
Yeah, thank you so much for having me.
Yeah. And thank you guys again for joining. As always, we are going to have another meetup soon. If you want to speak at the next meetup or webinar, and also let me know whether you like this webinar format or you would like to meet in person. Uh, so yeah, just message me on the Slack, or I'll carry out a poll on meetup.com and see what you guys feel. And yeah, I'll let you know soon with what are the plans for the next meetup. And till then, see you guys. See you,
All right.
Daniel. Bye.
Bye.